Pythagorean theorem in geometry. Pythagorean theorem relates the three sides in a right triangle. Specifically, in a right triangle ABC, with two legs of length A and B, and hypotenuse of length C, we have A square plus B square is equal to C square. The Pythagorean theorem is one of the most frequently used theorems in geometry. Many geometry problems can be solved by building right triangles and then applying the Pythagorean theorem. The converse of Pythagorean theorem is also true. If a triangle with three sides satisfying the Pythagorean relation, a square plus b square is equal to c square, we can conclude that it is a right triangle. The theorem is named for the Greek philosopher Pythagoras, born around 570 BC. We prove Pythagorean theorem using similar triangles. To create similar triangles, we draw a line from point C, perpendicular to side AB, at point D. Based on angle-angle similarity rule, triangle BCD is similar to triangle ABC, thus we have area of triangle BDC over area of triangle ABC is equal to A square over C square. Similarly, triangle DCA is similar to triangle ABC, thus we have area of triangle DCA over area of triangle ABC is equal to B square over C square. Adding equation 1 with equation 2, we get equation 3. The area of triangle ABC is equal to the area of triangle BCD plus the area of triangle DCA. By substituting the area of triangle ABC into equation 3, we get equation 5, which can be simplified to A square plus B square is equal to C square. Therefore, Pythagorean theorem is proved. A Pythagorean triple is a set of three positive integers, satisfying A square plus B square is equal to C square. For example, 3, 4, 5 is a Pythagorean triple. Here we list a number of primitive Pythagorean triples, in which the three numbers have no common factor. Of course, we can derive numerous Pythagorean triples from the primitive Pythagorean triple. For example, multiplied by 2 to 3, 4, 5 Pythagorean triple, we can get 6, 8, 10 Pythagorean triple. If the three side lengths of a triangle form a Pythagorean triple, this triangle is a right triangle. Next, let's look at an example problem. Please pause the video and read the problem. In this problem, what we know is radius of the two concentric circles, and what we want to find is the length of chord AB. For such a problem, what we need to do first is to put the known radius and the unknown segment into a triangle. How can we put them into a triangle? We can draw additional lines to construct triangles. We draw the first line from center O to point B, the second line from center O to point D, and the third line from center O to point E, which is perpendicular to line AB. By drawing the three lines, we create two right triangles, triangle OED and triangle OEB. Then, we can apply Pythagorean theorem on the two right triangles to solve the problem. Now, let's work on the solution. Since segment OD is the radius of the small circle, we have OD equal to 7. Also, segment OB is the radius of the large circle, we have OB equal to 9. It is given that chord AB trisects the two circles. Therefore we have AC equal to CD equal to DB. Since line OE is perpendicular to chord AB, point E is the midpoint of chord AB. We denote segment ED as X, then segment EB is equal to 3 times X. By applying Pythagorean theorem on triangle OED, we have OE square is equal to 7 square minus X square. By applying Pythagorean theorem on triangle OEB, we have OE square is equal to 9 square minus square of 3x. After combining equation 1 and equation 2, we get equation 3. Solving equation 3, we get x equal to 2. Therefore, the length of segment AB is equal to 12. In summary, Pythagorean theorem relates the three sides in a right triangle. Pythagorean theorem can be used to solve geometry problems, where a right triangle is available or can be created, and one or two side lengths of the right triangle are given or can be found. If you are interested in learning more math theorems or techniques, please visit our YouTube channel Maths in Minutes. If you like the video, please press the buttons of subscribe, like, share, and feel free to comment.